Hey guys, welcome back. We'll continue with the book Automate the Boring Stuff with Python. And in this video we're going to cover how to keep time, schedule tasks and launch programs. You can follow along for free by heading over to automatetheboringstuff.com, or if you prefer a physical copy of the book, you'll find a link in the description down below. When we write programs, sometimes we don't want to execute them right now, but at a specific point in time or at regular intervals. For example, we could write a Python script that would scrape a website and get its content every hour, for instance. And to help us do that, we can use the time module in Python, which comes automatically with the Python standard library, meaning we don't have to install a separate module, but all we need to do is to open the REPL and then type in import time, and then we can type out time.time, and that's going to give us back the current time expressed as the Unix epoch. And that means the number of seconds since a specific point in time, specifically 12 AM on January 1st, 1970. And this number is called the epoch timestamp. We'll later on also see how we can convert that into a specific date, so it's a little bit more tangible. Now we can use this time method to profile code, meaning we can check how long the execution of a program takes, and then of course we could optimize our code. For that, let's have a look at this program here. We're starting out by importing the time module, and then we're defining a function calcprod, which is calculating the product of the first 100,000 numbers. So this is the function we want to check and see how long it takes to execute this. Let's have a look at this function itself. So here we have a product that is set to 1, and then we have a for loop that goes from 1 all the way up to 100,000, and then we multiply that product by that number and then set it to the product again. That means we are multiplying all the numbers from 1 all the way up to 100,000 together, and then we return the end result from that function. Now in order to see how long the execution takes, we first set up a variable start time, and then we get the current timestamp by calling the time function on the time module. So that will give us a specific point in time when we start our program here. After that, we are then calling the function calcprod to calculate that product up here, and then the return value will be stored in prod. And then after that computation has been done, we are calling time.time again, and that is going to be our end time. So since our program executes linearly from the beginning to the end, we can first get the start time, then execute our code here, so our function call, and after that we are calling time.time again, and this is going to give us back our end time. And then we are printing out what the result is, so the result of multiplying all these numbers from 1 to 100,000 together, and then we are also printing out how many seconds it took to actually calculate that result by subtracting the start time from the end time. So let's run our program, and here we can see the result. So the result is 456,569 digits long, so it's a huge number, and in this case here it took us 4.7 seconds roughly to calculate that. And knowing this number, we could then of course go ahead and maybe find out a better way to calculate this function here to reduce the time it takes to execute that function. So the return value we get from calling the time method on the time module is quite useful, but it's not human readable because we can't automatically convert those seconds into the appropriate date. And to facilitate that, we have the ctime method here. So again, we need to import the time module, and then we can call ctime on time, and that's going to give us back the specific date and time when we are actually executing this code. And we can also go ahead and basically convert the seconds that we get by calling the time method and then convert it to a specific date using the ctime method. To do that, let's just store the result of calling the time method on time in this moment, which is going to give us back the result in seconds. And then we can go ahead, of course, and call ctime and pass this moment here as an argument to that method. And again, that's going to give us back the current date in human readable form. Now, sometimes we may want to write a program that actually stops execution for a while, for example, because we're waiting for some user input, or because we want to make some output more readable. For that, we can use the sleep function, and that of course is also part of the time module. So let's import the time module first, and then we can write a for loop, and here we can then print out tick. Then we use the sleep method here and pass a value of 1 to it. That means we are going to stop execution for 1 second. And then we continue and print our toc. and then again we stop execution for 1 second. So let's run this program, and we can see here tick and tock is printed out, but always with a small delay. And we can of course also go ahead and stop execution for a longer time period. So for instance, if we want to stop execution for 5 seconds, we will pass a value of 5 to it. And that's then gonna take a certain time frame, 5 seconds, until right now we can continue execution. Now when we're working with times by calling, for example, time.time, we'll often encounter situations where we have a lot of digits after the decimal point, and it's often easier to round those values. And for that we can use the round function, and for example say that we only want to have a look at 2 digits after the decimal point. So let's have a look at an example. We are importing the time module, and then we are getting the current time frame in seconds by calling the time method here on the time module and storing the result back in the now variable. And if we take a look at the value of now, we can see that's a number that has 7 digits after the decimal point. If we want to shorten the number a bit, we could round that number. For that we simply call the round function and we pass the number we want to round, so in this case now, as the first argument to it, and then after a comma the second argument, which specifies how many digits after the decimal point we want to round to. So here we are rounding to the second digit, and as we can see we get 0.71, so it is rounded after the second digit. If we want to get a more precise result, we can of course also round, for instance, to the fourth digit after the period point. So for that we can see we have a 0 here, but there's a 9 right after it, so we should get back 0.7101. And we can see Python does the rounding for us, we just need to use the round function. We can also use the round function without a second argument. In that case we are going to round to the closest number without any decimal point. We're gonna get back this whole number here without any decimal point. Let's see how we can apply what we learned about the time module to write our own project. We are going to write a program that creates a stopwatch. So when we press enter, we're going to start our stopwatch. And then as we press enter again, we are getting an update of how much time has passed. And we can do that multiple times and basically get the lap time, so the time difference between the last time we pressed enter and also the overall time that has passed. Let's have a look at how we can accomplish that. And to do that we need to, of course, first import the time module, and then we are going to provide some instructions. So specifically we're going to print out that the user has to press enter to begin, and then it needs to press enter again to basically click the stopwatch. And by pressing Ctrl C we can then quit our program. So to start out we are calling the input method here. That basically asks the user for some input, and as soon as the user presses enter we are basically starting. Then we're printing out started, and we are getting the current time by calling the time method, and we're storing that back in start time. And we are also initializing a second variable that we're gonna need a little bit later called last time, and we're setting it initially to the same value as start time. We are also keeping track of the number of laps that we are taking, so we are setting lap num to 1. And then we can start out by tracking the lap times, and then we're using Ctrl C to quit our program, and we want to avoid that we have some error messages showing up. We are using a try except block here. And if we are using a keyboard interrupt, meaning if we press Ctrl C, then we're just gonna print out done. But while we are not doing that, we are always asking for the input for a user. So if the user presses enter, then we are taking the difference between the current time by calling the time method here and the value stored in last time. So in the beginning that would just be this time when we started our program. And to avoid having a very long number, we're rounding it to 2 digits after the decimal point. We also keep track of the total time. So for that we are subtracting start time from the current time, so not the last time but the start time. And again we're also rounding that to 2 digits. And then we're always printing out the lap number. So is it the first lap, the second lap, so on and so forth, the total time that has passed, and then also the lap time. And the lap time here is printed out in parentheses. We are then incrementing the lap number by 1, and of course we also need to update the last time, and we need to set it to the current time. So let's run our program to see that in action. So here we have our instructions, and let's press enter to begin. So here we can see we started. Let's press enter again. We are in the first lap. We can see the total time that has passed are 4.23 seconds. And since we're in the first lap, the lap time is exactly the same. But as we press enter again, we can see the total time has been updated accordingly. So it's now 15.5 seconds. but the lap time is only 11.28 seconds. And of course we can continue doing that. We see that the total time is always increased, and then here we can see that the lap time of course is just a difference. And when we are done, we just press Ctrl+C, and that's going to then stop execution of our program. The time module we looked at so far is really useful for getting the Unix epoch timestamp to work with, so the amount of time in seconds since 1970. But if we want to display a date, there's a better module we can use. Specifically, we can use the DateTime module that is used to display dates in a more convenient way. And we can, for example, also do math with it and calculate how many days ago a certain day was. So let's see how we can work with it, and let's start out by importing the DateTime module. And then we can, for instance, have a look at the current date by typing out datetime.datetime and then calling now on that. And that's gonna give us back the current date, so the year, the month, the day, and then the hours, minutes, and seconds. And of course we can also use the DateTime module to create a specific date. So here we are calling DateTime on the DateTime module, and we're passing in the year, month, day, as well as the hour, minutes, and seconds. And we are storing that in DT. And if we now want to get back specific data points out of that, for example the year, we can just type in dt.year, and that's going to give us back the year. We can also get back multiple entries at once, so for example the year, the month, and the day. It's just important that we separate that by the comma, and then we get back this tuple here that's giving us back the year, month, and day, and of course that's the same information as up here. And of course we can do the same for the time, so here for hours, minutes, and seconds. We can also convert a Unix epoch timestamp by calling time.time, for example, to a datetime object by using the function from timestamp. And let's have a look at that. So here we are importing the DateTime module and the time module. And then we are using datetime.fromTimestamp, and we pass in a value of 1 million. So that's going to be 1 million seconds after January 1st, 1970. And this is going to give us back January 12th, 1970 at 14:46 and 40 seconds. And of course we can also pass in the current time, so by calling time.time and passing that as an argument to from timestamp. And that of course is going to give us back the current date and the current time. So that's basically the same as calling datetime.datetime.now, which is basically going to give us back the same date and time. We can also compare datetime objects with each other to find out which date comes first. So as an example, we are here, of course, first importing the DateTime module, and then we have 3 different dates: Halloween 2019, New Year's 2020, and October 31st, 2019, which of course is the same as Halloween. So here we are creating the DateTime object accordingly. So you can see in the second entry here we have January 1st, 2020, and the first entry here and the last one are the same, so October 31st, 2019. And now we can go ahead and compare those dates to each other. So for instance, we can check if Halloween 2019 is indeed the same date as October 31st, 2019. And here we get back true, because based on the date time we provided here, they're exactly the same. We can also check if Halloween 2019 is greater than, so has a date greater than New Year's 2020. And that of course is false, because New Year's 2020 of course is after Halloween 2019. So we get back false. But if we then of course check if New Year's 2020 is greater, so comes after Halloween 2019, that of course is true. And we can also check if 2 dates are not the same. So here we are comparing New Year's 2020 to October 31st, 2019. And they are of course different, so we get back true when we check for if they are different dates. If we want to work with a duration rather than a fixed point in time, we can instead use the time delta data type. And let's have a look at an example. So here we can see we have the time delta method, which takes a number of days, hours, minutes, and seconds. So the duration of that rather than a specific date or time. And we can then have a look at, for example, the days, seconds, and microseconds. And here we get back 11 days, so the first entry, and then 36,548 seconds. That's basically the sum of hours, minutes, and seconds converted to seconds. And we have 0 microseconds here because we didn't specify the microseconds when we created our time delta variable here. We can also have a look at the total seconds, so converting days, hours, minutes and seconds all to seconds. So we get this number of seconds here, 986,948 seconds. And we can use the time delta function for calculations. So for instance, we can get the current date here by specifying DateTime.now. And if we check that value, we can see that is June 20th, 2022. And then we can use time delta and pass a value of 1000 days to it. And now if we add those 1000 days to the current datetime value, we get this timestamp back. So we can see 1000 days will be on March 16, 2025. So the time delta function is really useful when we want to add up a time span to a date. We can also convert datetime objects into strings and vice versa. And here's an overview of the different directives we can use to accomplish this. So for example, %Y will be interpreted as a year with a century, for example 2022. Then %y will be the year without the centuries, so for example 2020. And then we can, for example, also reference the month, the full calendar name, or the day of the month. Let's have a look at an example. Here again we are importing the DateTime module, and then we are creating a date here, October 21st, 2019. And now we can take the strf time method, which we call on our date here, and then we can specify the format. So in this case here we want to display the year, the month, the day, and then the hour, the minutes and the seconds. And that's exactly what we get back here. And this method here gives us a lot of control of how we want to display our date or time. So as another example, let's say we are not interested in the actual date, but we want to display the hour, minutes, as well as if the time is AM or PM. We would pass that as an argument to our strf time method, and this returns 4:29 PM. So we basically converted this 24-hour timestamp here to PM and displayed that properly. And we can also do the reverse, so we can convert a string to a datetime object. For that we are using the strp_time method here, and then we pass the string to it and also the format. So in this case here we have the full name of the month, then the day, and then a comma and then the year, and we want to convert that to a datetime object. And here we can see how that would look like. So here we have datetime, the year, the month, the day, and then hours and minutes, which have not been provided, so they are set to 0. So to briefly review what we covered, we first learned about the time method, which is part of the time module, and that gives us back the Unix epoch timestamp, so the number of seconds since January 1st, 1970. But in order to cover dates, the datetime object is actually much more useful. So for that we have been using the DateTime module, using for instance the datetime method in order to specify a specific date, or we use DateTime.now to get the current timestamp. And then to have a look at a duration rather than a fixed point in time, we have been using the time delta object, which is also part of the DateTime module, and this can be really useful to represent a time duration, for example a time period of let's say 100 days. Now so far we have been looking at programs that are single-threaded, meaning they start at the very beginning and then the entire program is executed from top to bottom. So here for example we have a program where we are defining a start time using the DateTime method, and then we are executing some additional code, and at the end we are printing a statement. However, we can also write programs that are multi-threaded, so where there's more than one flow of action. And here's an example program for that. We are importing a new module called threading, and then we are defining a function here that is using the sleep method to stop execution of our program for 5 seconds, and then it prints out wake up. And then we are using our threading module here, and we pass a target to thread, and we set that equal to the take a nap function here. And then we say that the thread object that we defined should start. So now as we run our program, we will first print out the statement here on top, and then end of program at the end. This is the first thread, but we do have a separate thread where we have the target of take a nap. So as we call thread object start, we are then triggering this second thread, and in here we are calling the take a nap function. And after 5 seconds, we are then going to print out wake up. So let's run our program to have a look at that. We can see we print out start of program and end of program. and after 5 seconds we are then printing out wake up. And so when we are writing Python programs, those programs will not terminate until all of its threads have terminated. Now, using this threading module, we can easily create several new threads and have them run all at the same time, but we may encounter some issues when we are doing that. Specifically, we can encounter some concurrency issues where we have multiple threads running at the same time, which maybe access the same parts of code and, for example, change variables in a way that can cause our program to not run as expected. So writing multi-threaded programs can be quite of a tricky subject. So we definitely have the option to write multiple threads, but we should be aware that we introduce an additional level of complexity if we decide to do so. Let's have a look at a project using multiple threads. And here we are going to write a similar program to a program we already wrote before, where we were working on web scraping. And specifically, we want to download all the XKCD comics from the internet. When we implemented that in a previous video, we used a single-threaded approach, and that worked fine, but as long as we have a fast internet connection, we could use multiple threads and therefore actually speed up the process and make our program more efficient. So as a quick reminder, we imported the requests module, also the OS and the beautiful soup module, and now of course we also need the threading module. Then we are creating a new directory using the OS module, which we call XKCD. And this is the location where we want to store all the comics that we are downloading. And then we define a function download XKCD, which starts with the very first comic and goes all the way through to the last comic. And since those comics are numbered, we can then just adjust the URL number accordingly. We're printing out that we are downloading the specific page. Then we use requests.get to get the specific comic. And the structure is this one here. So it's xkcd.com/ and then the number, for example, 1 or 12. We call raise for status to see if our requests work properly. And then we use beautiful soup to get our request object. We find the URL of the comic image. Specifically, we are referencing the src, so the source HTML tag. And then finally, we save the image to our folder that we created initially. And finally, of course, we need to close the file that we created. Now, this was pretty much the previous code that we've been using. Now we are going to work with multiple threads, and for that we are creating a list of download threads, and we are going to create 14 separate threads which we can use to download those comics. And then we're using our threading module here. As a target, we provide our function download XKCD. It's important to not include the parentheses at the end because we are not calling our function here, but we are just referencing it as the target. And then we append that newly created thread to our download threads list that we specified in the beginning and start that thread. And then we are basically waiting for all the threads to end. So here we are looping over each download thread in our download threads list. So all 14 threads. And then we call the join method here. And this will basically block this until the thread has finished. And at the end, we're going to print done. So let's run our program. And here we can see we are downloading the different comics. So this is taking a little while, but we have those multiple threads running at the same time. And then at the end, of course, we are printing out done. That means the execution of our program has stopped. And now if we take a look at our mu code directory, we can see we have a new folder called XKCD. And as we take a look at that, we can see the various XKCD comics which have been downloaded from the web and are stored in this directory. Now we can also use Python to start other programs on our computer. And for that, we would use the popen function, which is part of the built-in subprocess module. And to work with that, we can go ahead and import the subprocess module. And then we can go ahead and use the popen method to open a program. So for example, we could open the calculator file. We can find out the application name that we want to start by right-clicking and having a look at its properties. But in this case, if I run this, then this is going to basically start the calculator here, and that will be displayed. And this is a new process that's being started. So if I run this again, we basically have now new 2 instances of the calculator. So whenever we call popen, this is going to start a new process on our computer. And within that process, there could be multiple threads that are running for it. Now let's work on a project that's using those principles. So here we are going to import the time module and also the subprocess module. And then we are going to implement a countdown timer. We have some time left. for example 60 seconds. And while that timer has not expired, so has not decreased to 0, we're going to print time left. Then we are going to wait for 1 second, and then we are going to decrement time left by 1, so basically counting down from that number here. And then at the end of the countdown, we are going to use popen to play a sound file. So here on Windows, we are going to use the alarm.wave file, which is a default sound being used on Windows. And just to make it a little bit more visible, let's actually change the time left to 6 seconds. And then let's run our program. And we can see we are counting down here from 6 all the way down to 0. And we always have a 1 second interval. And then as it gets down to 0, that sound file is going to play. Let's have a look at the practice questions. First one, what is a Unix epoch? So we learned about that when we worked with the time module. And the Unix epoch is a reference moment that many date and time programs use. And the starting point there is January 1st, 1970. And from there, when we use the time method, for instance, we are counting up the seconds. And this is what we get returned when we call the time method, which is part of the time module. What function returns the number of seconds since the Unix epoch? So for that, we are going to use the time method, which is part of the time module. So we need to import that first, and then we can call time.time. How can you pause your program for exactly 5 seconds? So for that, we are going to use the sleep method, which is also part of the time module. And we pass the number of seconds as an argument to the sleep function here, which specifies how long our program should be paused. What does the round function return? So the round function returns the closest integer to the argument passed in. So for example, if we call round with an argument of 2.4, we're going to get back a value of 2. But we could also pass a second argument to it, which specifies how many decimal places we want to round to. What is the difference between a DateTime object and a time delta object? So a DateTime object represents a specific moment in time, specific date, and a time delta object represents a duration of time, for example 100 days. Using the DateTime module, what day of the week was January 7, 2019? So to figure that out, we first need to import the DateTime module, and then we are going to use the DateTime method here. We pass in 2019 for the year, 1 for the month of January, and then 7 for January 7th. And then we call .weekday to figure out the weekday. And if we run that, we get a value of 0 back. That means Monday. So it basically uses 0 for Monday, 1 for Tuesday, and so on and so forth. Say you have a function named spam. How can you call this function and run the code inside it in a separate thread? So for that, we need to make sure that we import the threading module. And then we are going to create a new thread object by calling thread on threading. And we pass target to it. So if we have a function named spam, then we would pass that as the argument. And then we need to call start on thread object to actually start our thread. What should you do to avoid concurrency issues with multiple threads? So that can lead to some issues. We should definitely make sure that the code running on one thread does not read or write the same variables as the code running in another thread. We learned how to time our programs using the time module and also the DateTime module. We also covered how to work with multiple threads using the threading module. And finally, we also learned how to launch other applications using the subprocess module and specifically the popen method. In the next video, we are going to cover how to send email and text messages. Feel free to subscribe to the channel to stay up to date about any new videos, and see you guys in the next video.